हेलो स्टूडेंट्स, हाउ आर यू? कैसी तैयारी चल रही है? वेलकम टू माय चैनल। इफ़ यू हैव नॉट सब्सक्राइब माय चैनल येट, प्लीज़ सब्सक्राइब इट बाय प्रेसिंग द सब्सक्राइब बटन। बहुत लोग चैनल को देख रहे हैं लेकिन सब्सक्राइब नहीं कर रहे हैं। प्लीज़ सब्सक्राइब द चैनल to support the channel. Today I shall discuss one more topic in basic concepts of chemistry. First, I shall discuss about percentage composition. What is percentage composition? And after that, I shall discuss about empirical formula and molecular formula. How we can obtain empirical formula and molecular formula if percentage composition is given. Suppose an unknown compound or new compound is given, then one would ask the question, what are the different constituents present in the compound, or what are the ratio of different elements present in the compound, or what is the formula of the compound. So in order to discuss the percentage composition, we have to obtain the percentage of different elements present in a compound. By percentage composition, we can also check the purity of sample or compound. We can check the purity of given compound. Now, the percentage of different elements present in a compound can be calculated by the following equation. Percentage of element, percentage of given element is equal to mass of element in the compound divided by molar mass of the compound multiplied by 100. So percentage of element is equal to mass of element in the compound divided by molar mass of the compound into 100. By this formula we can determine the percentage of different elements present in a compound. In order to clear this formula, let us take the example of water. The molecular formula of water is H2O. In water, two elements are present. One is hydrogen, another is oxygen. So first of all, determine the molar mass of water. That is molar mass of water. We can determine the molar mass by the atomic masses of different elements. Here two hydrogen atoms are present, therefore 2 into 1.008 plus 1 oxygen atom is present, which is equal to 16.0. After addition, we get molar mass of water is approximately equal to 18.02. Molar mass of water is 18.02. Now the percentage composition of hydrogen in water. Percentage composition of hydrogen in water is equal to mass of hydrogen. Since there are two hydrogen atoms, therefore 2 into 1.002 divided by molar mass of water, 18.02. multiplied by 100. After simplification, this comes out to be 11.18%. The mass percentage, the percentage of hydrogen in water is 11.18%. Similarly, we can determine the mass percentage of oxygen in water. Since one oxygen atom is present in water, therefore mass of oxygen is 16.00 divided by molar mass of water, which is equal to 18.02 multiplied by 100. This comes out 88.79%. So we see that in case of water, the percentage of hydrogen is 11.18%, while the percentage of oxygen in water is 88.79%. So by using this formula, we can determine the percentage of each element present in a compound. Now take another example. Let us take the example of ethanol. In case of ethanol, we can determine the percentage of each element in ethanol. The molecular formula of ethanol is C2H5OH. Here three elements are present: carbon, hydrogen and oxygen. Three elements are present: carbon, hydrogen and oxygen. Now the molar mass of ethanol C2H5OH is equal to, since two carbon atoms are present, 2 into 12.01 plus 6 hydrogen atoms are present, 6 into 1.008 plus 1 oxygen atom is present, 16.0. After addition, the molar mass of ethanol can be obtained. Here it is 24.02. This is 6.048 and 16.0. This comes out to be 46.04. Therefore, the molar mass of ethanol is 46.04. Now we can determine the percentage of carbon in ethanol. Mass percentage of carbon in ethanol. The mass of carbon in ethanol is 2 into 12.01 divided by molar mass of ethanol. Molar mass of ethanol is 46.04 into 100. This comes out to be 52.14%. Similarly, percentage of hydrogen in ethanol is equal to mass of hydrogen, total mass of hydrogen. 6 hydrogen atoms are present, therefore total mass is 6 into 1.008 divided by molar mass 46.04. This comes out to be 13.13%. Therefore, percentage of hydrogen in ethanol is 13.13. Similarly, the percentage of oxygen in ethanol is equal to atomic mass of ethanol, atomic mass of oxygen, which is 16.0, divided by, since only one oxygen atom is present in ethanol, divided by molar mass 46.04 into 100. This comes out to be 34.73. Thus, we have determined the mass percentage of carbon, hydrogen and oxygen in ethanol. Percentage of carbon is 52.14%, percentage of hydrogen is 13.13%, and the percentage of oxygen is 34.73%. Thus, we can determine the percentage composition if you know the molar mass and masses of different elements present in the compound. Now, let us see what information we can obtain if percentage composition of different elements in a compound is given. If we know the percentage composition of different elements in a compound, then what information we can obtain? We can determine the empirical formula and molecular formula of the compound. By using the percentage composition data, we can obtain the empirical formula and molecular formula. First, I shall explain what is empirical formula. What is empirical formula? Empirical formula. Empirical formula gives the simplest whole number ratio of different elements present in a compound. What is the simplest whole number ratio of different elements present in a given compound? This information is given by empirical formula. However, molecular formula by molecular formula, the exact number of different elements present in a compound is obtained. By molecular formula, we obtain the exact number of different elements present in the compound. For example, if C2H6 is ethane, then this is the molecular formula. This formula gives the information that 2 carbon atoms and 6 hydrogen atoms are present in ethane. This is called molecular formula. But if we take the simplest whole number ratio, we can divide by 2, then it is CH3. CH3 is empirical formula. It is empirical formula of ethane. This gives the simplest whole number ratio of different elements present in ethane. Now, let us take one example how we can calculate the empirical formula or molecular formula if percentage composition of different elements are given. If percentage composition of different elements are given. Let us take one example. The empirical formula and molecular formula will be obtained in few steps. Let us take one example. In a compound, in a given compound, the percentage of hydrogen is 4.07. The percentage of carbon is 24.27%, and the percentage of fluorine is 71.65%. In a given compound, percentage of hydrogen is known, it is 4.07, percentage of carbon is known, it is 24.27%, and percentage of chlorine is known, it is 71.65%. And the molar mass of compound is 98.96 gram. 98.96 gram. Then we have to obtain empirical formula and molecular formula of the compound. The question is clear. Percentage of hydrogen, carbon and chlorine in the compound is given. Molar mass of compound is given. We have to find empirical formula and molecular formula. How we can obtain the empirical formula and molecular formula. Solution. In the step 1, first step, we convert the mass percentage into grams. In the first step, convert mass percent into grams. Let us assume that originally 100 gram of compound is present, then mass percentage can be converted into grams. Masses of different elements. Therefore, hydrogen is 4.07 gram, carbon is 24.27 gram, and chlorine is 71.65 gram. In this step, we have converted mass percentage into grams. Now, in step 2, we have to obtain number of moles of each element. Number of moles of each element by dividing masses of different elements by their atomic masses. Here, the number of moles of hydrogen has mass 4.07 and the atomic mass of hydrogen is 1.008. Therefore, it comes out to be 4.02. Similarly, the number of moles of carbon, the mass of carbon is 24.27 divided by atomic mass of carbon, it is 12.01. It comes out to 2.02. Similarly, the number of moles of chlorine is equal to mass of chlorine, it is 71.65 divided by 35.45. It is approximately 2.01. In the second step, we have obtained the number of moles of each element. Now, divide the number of moles of each element by the smallest value of number of moles. Here, the smallest value of number of moles is 2.02. Therefore, divide this. In step 3, we divide the number of moles by smallest number. Therefore, first carbon is to hydrogen is to chlorine. In case of carbon, 2.02 divided by 2.02, we obtain 1. It is 1. Similarly, in case of hydrogen, 4.02 divided by 2.02, it comes out to be 2. And in case of chlorine, 2.01 divided by 2.02, it comes out to be 1. Therefore, the simplest ratio is 1:2:1. If the simple whole number ratio is not obtained in this step, then we multiply by suitable coefficient in order to get simple ratio. Therefore, carbon, hydrogen, chlorine has ratio 1:2:1. In the fourth step, in the step 4, we write the empirical formula. We write the empirical formula by writing the symbol of each element with their coefficients, followed by their coefficient. In case of carbon, coefficient is 1, in case of hydrogen, coefficient is 2, therefore CH2Cl. The empirical formula is CH2Cl. Empirical formula of compound has been obtained, CH2Cl. In the last step, we determine molecular formula. In step 4, in step 5, we determine the molecular formula. In this step, first we determine empirical formula mass. Empirical formula mass. Empirical formula mass can be obtained by the addition of atomic masses of different elements present in empirical formula. One carbon is there, therefore 1 into 12.01 plus 2 into 1.008 plus 1 into 35.45. Therefore, the empirical formula mass comes out to be 49.48. Empirical formula mass comes out to be 49.48. The empirical formula mass of the compound is 49.48. It is obtained by adding the atomic masses of different elements present in empirical formula. Now, the molar mass is given. Molar mass is 98.96. In this step, we divide molar mass by empirical formula mass. Molar mass is 98.96 divided by 49.48. It comes out to be 2. This ratio is 2. Now we can obtain the molecular formula. Molecular formula is empirical formula multiplied by n. This factor is called n. The ratio of molar mass and empirical formula mass is called n. Empirical formula is CH2Cl multiplied by 2. Therefore, the molecular formula is C2H4Cl2. The molecular formula of the compound is C2H4Cl2, while the empirical formula is CH2Cl. So, in this example, we have determined the empirical formula and molecular formula by using the data of percentage composition and molar mass of the compound. In first step, we convert mass percentage into grams. In the second step, we obtain the number of moles of each element. In the third step, we obtain the simplest ratio of number of moles of different elements. In fourth step, by the simplest ratio, we obtain the empirical formula. In the last step, we determine the molecular formula. First, we determine empirical formula mass, and by the ratio of molar mass and empirical formula mass, we obtain the coefficient n, and by multiplying empirical formula by coefficient n, we obtain the molecular formula. So today I have discussed about percentage composition of different elements present in a compound, what is its formula, how can we determine the percentage composition of a compound, and second thing I have discussed about empirical formula and molecular formula. Empirical formula represents the simplest whole number ratio of different elements present in a compound, while the molecular formula gives the exact number of different elements present in the compound. By using the percentage composition data, we can obtain the empirical formula, and if we know the molar mass of compound, then we can determine the molecular formula also. Thank you for watching the channel. Your comments are welcome. Please subscribe the channel. If you have any query, you can write in the comment box of. Thank you once again.